I'm a very big fan of that way of using
I
stuff.
mean, it's the way it's supposed to.
I know. My dad always argues with me whenever I use it that way. It's not the right way.
Wait, so we have something on Thursday and Friday?
Okay, yeah. Basically, every Friday is a one question, three response game with followed up by a worksheet on any random topic that we should have been able to do by then, but might be a little rusty. Hang on, Steve. So, like last week was definite integrals, plugging in the numbers, and we went over that sheet yesterday. This week we're the worksheet that I have planned is implicit differentiation because we did it, we did okay with it, took a quiz on it, we did okay with it, and then you promptly forgot it. Isaiah, I see the look of no. Well, no, but you need to still be able to do the derivatives with them. In particular, you need to be able to do the double derivative of those. That's what I'm concerned about. So,
Double derivative.
so every Friday there will be a question. Granted, it's a question like this that's bigger and more involved, and you'll have a 15-minute time to do it. So yes, there's something Thursday and Friday. BC Calculus, we often have 2-day tests, so don't complain. Keith, what was your question? An extra sheet, yes. So
Can I also have one?
I know, I'm getting.
So upset.
So who else needed one? If you have nothing written, you guys should write something. Try the problems.
For number 3?
No, I don't do number 4. I did it yesterday.
And guys, remember, I did not do the third one with you. That one is exceptionally hard.
Can we try it?
I would rather you try number 4 first if you didn't do either one. And then if you finish number 4, by all means do number 3. Get the back. Okay, so the Delta Math asked, I was able to say very specifically, ask them this kind of question. And I can't ask all of those, that was an hour and a half long Delta Math. I can't ask all variations on the test. I want you to be familiar with all the variations so that the one that you get will be there.
But what I'm saying is for the Delta Math is the exponents on my ln, but
Okay.
each class is mostly focused on these graphs and other things.
All right. So yesterday I said if you got something like this, that's one thing I can't control. Where if it asks you to integrate 3 to the x, you won't see that. However, the reason I can't turn them off is I can ask you to integrate e to the x, and on Delta Math, it sees these as the same, and they're not. There's a really small difference, but they're not. I do expect you to be able to integrate e to the x, which is e to the x plus c. Thank you. And integral of e to the 2x.
Never mind.
Wrong way. E to the 2x divided by 2 plus c. Because when you're integrating, you need to divide by the derivative of the thing inside. So, Noah, if you see one like that in the problem, you can disregard it. However, e to the x, you might need to integrate. And the integral of 1 over x, you need to be able to do those. Maya?
Endpoints don't have to do with
Endpoints, it would give you an open, they'll never ask you about the derivative at an endpoint. They will always say round brackets, something other. Because you're right, how do you say what the slope is at the starting point? You kind of need to know what happened before, and if you know what happened before, then that's not the starting point anymore, right? So Good point.
Well, it's just from 4 to 1. Well, yeah. 1 to 3.
That's good. What G4 is. Yeah. You got one?
No, wait a minute. Yeah. This one's negative, so that's right there.
Oh, I just think it's
Yeah, it's not 75.
Oh, yeah.
one is just. How many lines?
How do you do C? After that, how do you do C?
Forgot how to do C.
Well, I know I can kind of do. Do you still take critical points, or you just also use that?
Okay, anywhere that maximums and minimums happen, Cliff, get off the phone,
Changes.
is where the first derivative is 0 or undefined. And that's where that defines a critical point, where the first derivative is 0 or undefined. And then it's a maximum. Maya, when is it a maximum?
Sorry, what?
When does a function have a maximum?
The derivative goes from positive to negative.
When the derivative goes from positive to negative. Yes.
That's just the graph.
So it just said 3.
Okay, well, we gotta be careful because it says absolute. So where else besides critical points live? Where else can absolute maxes and mins happen?
Endpoints.
Endpoints. Okay? So, I realize you probably are not done yet. But Griffin, what does it mean, compute? Parks. Sorry. What does it mean, compute G of 4? Calculate. So how do I calculate this?
Area under the curve.
Okay. So, Eric, how do I calculate area under the curve from 1 to 4?
Well, from 2 to 3, 3 to 4 cancel out.
That's
But-
positive. This is negative. They undo each
1/2.
other.
Then you can just take that very wonky looking trapezoid and put it into a square and then a triangle. And the triangle is 3 by 1 over 1/2.
Or I could do the trapezoid formula, which is
Uh,
1/2 base 1 plus base 2 times the height, and the height is irritatingly this butt print.
Okay, that is another possibility.
Base 1 plus I'm like looking at the answer already. Do you guys agree G of 4 is 5 over 2?
Yes.
Maya?
I agree, but when I was doing it, I forgot that you could just look at the graph and do like the under thing. So then I was trying to do with just who's up there, and I got it wrong. So I want to know, like, you know what I'm saying? Like I did it without the graph.
I don't know how you could do this without the graph. Like, there is no F
No, wait.
function.
Wouldn't
You can't do it without a graph.
isn't it equal to like f prime of 4 minus f prime of 0? No, am I making that up?
You're making that up.
Okay.
Okay. G of 4 is 5/2. Carmen, how do I find G of -2?
You just find the area from 1 to negative 2.
Which is, okay, guys, height is 4, but dx was -3. You guys agree? So in the AP grading rubric, that's probably 1 point for each of those. So 2 out of the 9 points right there. Just finding areas of triangles, but it's a little tricky because you needed to make sure you knew G of 2 was negative. Any questions on those? Yes, no? All right. Josh, find the instantaneous rate of change of G with respect to x at x equals 1. What are they looking for?
G prime
Okay, so how do I find G prime of x? Is equal to f of x. Okay, so I am looking for G prime of 1. F of 1 is what? 4? So, Keon, Asher, what part are you guys working on?
We're on C.
C? Okay, so now that we're on C as well, what's the debate? What do you guys?
No, we're not, we were just a little bit confused.
Okay, well, like,
I was confused.
alright. Well, finding maximums and minimums, you had said,
It could be the endpoints for where it goes from. From negative. So that graph is that's the derivative graph of
that f of x, so,
yeah, it is.
yes, the graph given is the graph of the derivative, and you need to put this in your solution process somewhere.
So then you could just look at that graph and say like, okay, if it's 0 or it's an endpoint, like where is it changing sign?
All right. So guys, what he said, we got to find the critical points because maxes and minimums might happen at the critical points. There's exactly one critical point. It's here at 3.
But it goes from positive to negative, so it would be an absolute max, not a minimum.
It would be a maximum, which is not a minimum, correct? So my one critical point in the graph, the one place that my derivative is 0, is at x equals 3, and that's a maximum. So then checking the endpoints.
Yeah, which we already have both of them solved.
We already have both of them solved. There's part A was there to save you. So which one of those numbers looks like a minimum?
-2 because it's lower than, yeah, -6 is lower than 5,000.
Okay, careful. Said everything right, but one little glitch. What did the question ask? What is the minimum? You told me where it happened.
Well, okay, yeah, the absolute minimum is -6 at G of -2.
Right. However, all you said was it's at x equals -2.
Okay.
So, no. So this just pointing out, like, you get it. You've got the answer. You understand. And they will still bust you. This is what makes it an AP question.
Yeah.
So all that analysis, I'll look up the key in a second. But sometimes, like, you guys are good at this point, and you'll be like, I'll blow right over it because you're asking for a minimum. So I know this critical point's a maximum. I'm not even going to write that down and waste my time. Sometimes in the grading rubric, they'll say that you needed to consider it. To be like, hey, that's a critical point, and I know it's not the one I want. Sometimes they make you write that down. And it's arbitrary when they choose to do it. I cannot predict. And it's worse now that I'm a grader, because normally I'd be like, nah, it's got you. I believe that you understood that was going to be a maximum. We're asking for a minimum, so don't want that. But you never know. They're ornery. So the absolute minimum is -6. It happens at -2, at x equals -2. Okay. So, Will, what about this one? The second derivative of g is not defined at x equals 1 because second derivative is the derivative of this, or the slope of the first derivative, and it's not defined at 2. How many of these x coordinates of are points of inflection?
I think
actually do that one yet, but the inflection point, it would have to be where the slope equals 0 and it has to change the sign or undefined, I guess.
So an inflection point is where the double derivative changes sign. How do I read the double derivative off of the first derivative?
It's the slope.
Jessica?
Yeah.
Does it have to equal 0?
0 or undefined. Because right here, you're right. The slope at that dot is undefined. It's not 0. Where do we have an inflection point? Noah, what were you gonna?
Would be x equals 1 because the slope changes from positive to negative.
The slope of f changed from positive to negative, which is where a double prime changes sign. Yes. Is this at x equals 2, is that an inflection point? No, because the slope was negative for f and the slope stayed negative. Cool? Yes.
I have a question about C. If it was asking for like a relative minimum and you were just examining the endpoints or critical points, how come you wouldn't look at x equals 1? Because wouldn't that be a minimum of 0? But it's not.
X equals 1 is not a minimum. It is accumulating stuff. It's area under the curve. If I continue past 1, am I still getting more positive area under the curve? So it's not a maximum or a minimum.
Even if g of x is the integral from 1 to.
Okay, look at the values we found. G of -2 is -6. So right here, we're digging out of the hole. And finally, right here, we're at ground level. And then we kept going up. Is that a minimum there? No, you're finally at ground level and you kept increasing. Got tired right at 3, turned around and went down again.
But if you would have put like -2 or -1 into the equation, it would be negative. So how is it like going up?
Okay, G of -2 was -6. Let's look at the values that we calculated. X and G of x. At -2, we had -6. When we plug in 1, we've got 0. When we plug in 3, we had some other positive number.
It's
5 halves plus 1 half, 3. And then we plug in 4, and we had 2.5. So we were digging out of the hole from the start. We went up this whole time.
So if it was like, if we could see the graph of gx, it would have started like negative and then it would have went
Yes,
up.
yes. Okay, so to consider, let's look at what they say. So 1 point for finding each of those G values. 1 point connecting them together and getting that 4. Okay, right here. If you did not consider that critical point that was a maximum, even though we were looking for minimums, you needed to have said, like, hey, there was a critical point and it didn't matter. That was actually a point in here. And I would argue with them and I would lose because they tell me what rubric they're putting on the international test. But would you have known to do that? No. Like I so this one I feel that 1 point of the 9 is unfair. And that's what it is. So this is a warning shot that they can do that to you. Okay?
How many points total is there?
What is the interior?
38
analysis
points.
mean?
So what do you need to get a 5?
Oh, your AP exam. The test tomorrow is 38 points.
What?
38?
No, it's a test.
Yeah, you always make those like 20 points.
Yeah, it's a new quarter, new day, new.
different about this?
Oh, no.
Well, okay.
You should have more like non-test points, and then you just make all the tests more points.
The tests are more points. Yes.
I appreciate it. I appreciate it.
So everything else on the Delta map, except for like the weird like X whatever things are gonna be on like the test.
Okay, things that are on the test. Be able to integrate. Undo power rule. So integrate X. Integrate 1 over X plus 3. Be able to integrate e to the 2x. Be able to integrate sine.
Can you do all of those right now? Just like really quick.
Let me
Or
finish.
just
Let
do
me
them in
let's finish the topics.
Right.
Fundamental theorem of calculus. The derivative of the integral and being able to evaluate an integral.
I have like the where you add the integrals together, the rule, and like the one with the
Rules of definite intervals, being able to integrate a constant.
Is that like the one? It's like you have f of x plus 3. Like, I don't know, so then you have to take 2 integrals. Yeah, that. So then you add that integral, so like so the I just don't understand what you said. So what would that?
Okay, so we got a bunch of concepts up here, but L'Hopital's know the notation, show the notation correctly. I will bust you on it. I made a big deal of it, and then the sample free response question that we had that used it, you guys completely disregarded it. It will cost you if you don't pay attention to that tomorrow. Anyway, all right. So, not my L. The integral of x. Raise the power, divide by the new power, plus c.
Right.
This guy, what's the integral of 1 over stuff? Asher?
That would be ln.
ln, absolute value, x plus 3, plus c. And then I would have divided by the derivative of the stuff inside, which the derivative of the stuff inside is 1. I'm going to change the problem. You ready? What's it going to be now? Over 2.
Wait, what? Yeah.
This one was staying up to.
So this is still linear. It's not x squared. Once it's something squared, once it's anything other than x to the first, we're done.
What do you mean we're done?
We can't integrate this way. We got to do something different. But the integral of this, natural log of that stuff in an absolute value, divide by the derivative of this stuff. The derivative of that stuff is just 2, so I needed to divide by 2. We're kind of undoing chain rule. And Francesca, you had a question? 2 pages.
2 pages, 38 points.
front and back.
Front and back, like it needed a staple. It needed a staple. Amalia?
Does this come from last, like, unit 5 test from last quarter on this one?
Okay, guys, forever from now on, I can ask you about derivatives, which was chapter 3. Like, would Riemann sum be on it? It can be. So, on these free response question things that you will get on Fridays, they throw in stuff. So, you can't say, but that was chapter 2. You might still need to be able to understand how to do limits. I understand it's a lot of material. It is more on what we've done recently than big can of worms everything, but you need to be adept at those old material things. Hang on. I want to finish these though. What's the integral of e to the 2x?
e to the 2x goes over 2.
E to the 2x divided by 2 plus c. Asher, you asked what's the integral of 3? 3x plus c. So down here, if this went from 1 to 4, 1 to 4, I don't know what this one would be because I need to know the function.
Wait,
But-
so is that, well, wait, on the delta math, it was like, is that, so you just do like 3 times 3?
Yeah.
And add that?
Because this is, what is the area of, under the curve of y equals 3 from 1 to 4?
Oh, so you just add that to like.
Yeah.
Oh,
Yeah.
Oh, that's not.
And the number of you that on the test tomorrow, if you see this, you're going to just be like, plus 3. No, you need to integrate the,
That's what I did on the last gen.
okay, then don't do that this
Yeah,
time.
that's why I was looking.
You're a better man now, right? What's the integral of sine? Negative cosine plus c. Okay. Derivative of the integral, we did a worksheet on that. And be able to deal with the ends and the number of you that are checking your phones right now. Yeah, so,
Is that it?
I don't know.
Plus this 3 and then some 3 after that.
So you need to be able to integrate. You need to be able to plug things in. You need to be able to do the derivative of the integral, know they undo each other. And like old material, Noah, this stuff was old material, finding maximums and minimums, finding where is it increasing, decreasing, concave up, concave down. That's chapter 4. But it's now tied in with chapter 5. So you still, that's what I mean by, you're not allowed to forget the old stuff. Like I can still ask anything of this.
I take a picture.
Of it's not like spectacular or anything, but
No, but
It's not a risk word.
you know, no. It's about my standard work though. Yeah.
Can you quickly explain how to find the derivative of it?
Okay. Derivative of an integral. Indy, pick a function.
Yes.
X squared plus 3. I don't know. I'll pick a trig function.
Sine.
You're really going at it for this.
Actually, I don't.
This is gonna be rough. Let's see.
Okay. What's the what? Lanham, how do I do this? This derivative of this gross integral. Go.
So, I mean, can't you just plug it in and get the integral and then take the derivative of whatever you get? Because that makes no sense to me.
Well, how do I integrate f of x? I didn't tell you the function.
Oh, true. Then I have no idea.
Maya?
Derivative and integrals, they're inverse of each other, right?
They undo each other,
So-
but careful. Just like I said, square root and squared are inverses of each other, but that negative 5 squared came out as a 5. So you might have to do some adjustments. Same with this. So what is this?
This might be wrong, but is it not just the function with the straight bar? It's like the straight bar and then you.
But I can't integrate it. So that's what Lanham was saying, was just integrate it, but I don't know the function. Natalie, what's my adjustment that I need to do?
Probably wrong here, but I think you would do like 2x times f of, and then don't you have to subtract there? Then you subtract and you're gonna do the bottom function, subtract the bottom function out, it'll be derivative of the bottom function times f of the bottom function. Yeah, the bottom function.
Yeah.
Oh, that's
And now the derivative of this, well, the derivative of sine was cosine. And then the derivative of the stuff inside that, gross. So the derivative of the integral, just like the square root of something squared, should give the inside thing back. It kind of does. It's f of this, but then the adjustment, chain rule. Chain rule, derivative of x squared plus 3, 2x. And then this one, f of the bottom thing, chain rule, derivative of sine x cubed is a chain rule in itself. Derivative of sine is cosine, leave the inside alone, but then do the derivative of it. So then you get all this mess.
What if it's like x squared and then like 1 on the bottom?
Okay. 1 x squared, and we'll do this. So Lanham, I could integrate this. The integral of positive cosine is sine. evaluated from 1 to x squared. And so that's sine of x squared minus sine of 1. And then, if I said, just kidding, I wanted to do the derivative of all of these. The derivative of this, derivative of sine is cosine. Leave the inside alone, but now do the derivative of the inside, 2x. The derivative of sine of 1, that is, I don't know what the number is, but it's a number, so the derivative of that is 0. So I'm done. I could have just done the shortcut of stuff that in there,
Oh, that's what I was.
and derivative of this, or sorry, chain rule.
So
So that's the shortcut. So even if I could have integrated and then done the derivative, this is the shortcut. And you might not always be able to integrate.
if it's just like x on the top, then it's just the inside function.
Correct.
It's just the-
Because it's f of x times the derivative of x, which is 1, so yeah. Isaiah, then Eric.
If it was switched, then it was like the x squared was on the bottom, would it be negative?
So if the x squared was on the bottom, first of all, there's a rule for the integrals. What happens when I switch the bounds?
Well, I mean, in this case, you could just see it as since the constant's on top, your first value is going to end up being 0. So this is going to be 0 minus 2x cosine x squared.
So Isaiah, yes, and it could be because you did plugged in the 1 times
But also,
derivative of 1 is 0.
also there's a reverse on the graph.
And also, if it goes from A to B, if I turn it upside down, goes to B to A, it's the negative answer. So from A to B, if the integral was 5, switching from B to A, it would be negative 5. What else? This makes a lot more sense now. Good. Some days, like 6th period left, saying the opposite. I was a little sad. They're like, I don't understand anything anymore. Take my Legos and go home. Yeah, huge test. Huge.
This is gonna be the one.
Is
break
it
the
not
entire
huge?
quarter.
It feels pretty
Yeah.
huge.
Yes,
Wait, if this is 38, then how many points are there?
lots.
Oh.
There's lots of points in the universe.
Is it retakeable? Will there be
Tests are not retakeable.
What if everyone was poisoned?
Then y'all got a big hole to dig out of. Don't do poorly. Stay off your freaking phones. Yes.
It's gotta be the biggest test of the quarter, right?
No.
38 points is a lot.
She's just bringing it up because she was told she had 7 more points in different assignments, and
So we're gonna have bigger tests.
So they
Because
account
you
for
don't
the
wanna
same
do-
portion of points. It's just now that we have FRQs, it's like different. So all the tests have to be for more points if they want to count for the same amount of like our grade percentage wise. So it's the exact same as it was before.
All right. So for as much as you guys like argue over the points of this, that, and the other, I'd rather we argued about the content. Like,
There's nothing points of that.
there's nothing to argue about the content because
It's technically.
I'll win that argument. Yeah.
For Raymond's, there's left, right, and then there's the middle one, right?
Yep.
We were told
Can
not
you
to ask.
go over doing the middle one with a graph?
Okay.
Like if they give you the points on a graph.
Really, guys? Riemann sums, rectangles. We know how to find the area of a rectangle, base times height. So the only catch to these was, how do you find the height of the rectangle? So I needed to tell you, if we were going from A to B, and I said, you know what, guys, if I gave you values in a table or values on a graph, or just gave you a function, if I said do LREM, choose the left side of the rectangle to get the height, A, and then if I said these are 1 unit apart, this is plug in A plus 1 to get the height, A plus 2 to get the height, A plus 3 to get the height. Like, it's just area of a rectangle. And maybe I was like, you know what? Maybe we'll use the right side and we'll go that way. That's all. And midpoint is the one that's irritating because you gotta pick the number in the middle and say, oh, maybe you don't want that guy. But Riemann sums are just rectangles. And they will ask you, often they'll give you a table and say, you know what, we scientifically we observed this many birds coming to the migration area. And so what is approximately the number of birds that were there? Doing right rectangle approximation.
So for the middle, you just average right and left height.
So you would choose to find the height at a plus a half.
Okay.
It's not crazy business. So, I recommend you guys do belt math, but yeah,
Can you do the super hard one?
the super hard one. And really, the super hard one is hard because
The integral's
getting
hard.
started.
She's not gonna put a super hard one.
Don't ever.
Wait, the domain of H is just 0 to 5.
Asher, don't make me angry. I haven't photocopied this yet. I can do anything.
I'll photocopy it for you.
Wait,
I bet.
this, the
Yeah.
domain of H is 1, 0, 5, right?
Okay, so the domain of F is 0 to 5.
Okay.
The domain of H goes 0 to that thing.
I don't know if I like that.
How do we do this? Liv?
No, I just had another question. How do we know if it's round or square brackets on the end of that? Will a integral always be round or square brackets, or is it like, how does that work?
You're asking about how do we find the domain?
For A, for part A.
Okay, well, hang on. Let's think about this. How do I make this match up? You got an idea, or you got a delta math question?
Do this morning, yeah.
Okay, I can change that to be tonight. Sorry.
As long as you do it before you
Which could be
So yes.
anytime.
All
right. Guys, so my what makes this question hard is that very first question. I need to map this equation onto those numbers. You have any idea what I mean? Like what x value makes 0?
You said equal to 0.
-6.
Okay. So where is this equal to 0? That gives me the first bound.
-6.
Okay, how do I get the other end?
Say equal to 5.
So to me, it looks like the domain of H, because I need to be able to plug these x values in so that the things that squirt out go 0 to 5. To me, the domain looks like -6 to 4. And Liv, there were closed brackets here, so I'm going to have closed brackets there. Sydney? Oh, sorry. I thought, okay. So that first question is the hard one, and if you get that one wrong, it messes everything else up. Why do I do that?
I feel like that wasn't that terrible.
I wouldn't think.
You just had to think
You
about
say
it.
that.
What Miles said, I wouldn't have thought to do it.
And I still don't know why you did.
Okay, well, I want to be able to, any number I plug into this H function, it's got to fit in the domain of F. So the numbers can't bust out between 0 and 5 because I've got to be able to plug that in to F. The only numbers allowed in F are 0 and 5. So whatever x value makes it 0 is the start of the race. And whatever x value plugging into H that I plug in here makes me end at 5, that's the end of the race. So that's what we did right here was find the starting point, find the ending point. So that's part A. Then h prime of 2. Liv, what is h prime of x?
H prime of X is it's Yeah,
Missing something, yeah.
the derivative.
Thank you, Sam. So then plug in 2. Morgan, what do I get when I plug in 2? Awesome. So h prime of x is this. So plug in 2 for x. F of 4, looking at the graph, seems to be -3. -3/2. Yes, Samaya.
Why is there when we're like saying the relationship between F and the derivative of H, why do we like the bound of X?
Why?
Normally we'd say like H, the derivative of H equals like 2x.
Okay.
And then we're just kind of stuff in the parentheses, like why this.
All right. So the derivative of the integral, so part B, the derivative of this is an example like when Landon was like, oh, well, I would just integrate it and then do the derivative. I don't know what it is. So the derivative of the integral is f of that stuff, and then we gotta remember to do chain rule. And then they said, that's h prime of x. They asked us to find h prime of 2, just plug in 2 for x. Which I think that was -3, if I remember. Yeah. Yes, no?
It's just, I get like the math, it's just what's the
Difference between what? I'm not sure.
between knowing to do that and saying derivative of H of X is 2x.
Well, that this one had an adjustment to it, that it wasn't just to x. It wasn't integrating 0 to x. It was 0 to a function of x. Okay. And those of you that have extended time, be prepared to stay after class to take that time. Yes? Cool. Yeah. So that's it. You guys should do the delta math.